Hi, welcome to another week of control systems. In this lecture, what I want to talk about is performance of feedback control systems. What do I mean by performance? See, we have talked about control systems and we have talked about a process and trying to control the output of the process so that it is equal to the input or some relationship with the input. The question, however, is okay, I can do that, but how do I evaluate whether my control system is working well or not? Are there some measures to measure this performance? And those are the kinds of questions we want to answer, and we want to look at what those performance measures would be and how they can help us to design and evaluate control systems. Okay, the two basic types of performance measures that we are going to look at in this lecture are performance measures that are based on the transient response. Remember, in the earlier lecture, I talked about transient response. Transient response is the changing response. So if the input is a constant and it is changed to some other value, the control system takes some time for the output to reach a steady state value. Okay, so the intermediate period, the period when the output of the control system is still changing, is called the transient response. So the other category of performance measures are the steady state response. So after this changing behavior has finished and the output has reached its steady state, uh, you can have some performance measures there. So those are the two kinds of performance measures that we will look at. Now, in most control systems, it's not enough just to look at one performance measure, but several. And what we want to do is basically try to find the best possible measure for performance. So, for example, here on this slide, you can take a look. You can see performance measure M1 being plotted here and performance measure M2 being plotted here. So there are these two curves, and what you want to do is you want to optimize M1 and M2 in a certain way. Okay, and probably your the performance, maybe you define the idea that the performance of the control system is best when you have the minimum of M1 and the minimum of M2. What is the place where they get the least together? In that case, this would be this point, and maybe you want to design your control system to operate here. Or perhaps there is a different combination of these two performance measures. So probably M1 is more important to you than M2, even though M2 is important as well. So then you have a slightly different performance measure. And based on these kinds of performance measures that you build, you can optimize your control system.